Okay, I think I got this volume thing figured out, but I don't know if that's a good thing for you or a bad thing. But okay, tonight we're gonna take a quick look at the Virgo supercluster. Probably the best way to look for it is look for the question mark in Leo, and then see the triangle in the back, and kind of see it pointing back. Here you can see a Virgo, which is this looks like a trapezoid. Uh, you can see 6 stars there too. So, but that's what it looks like to me. Okay, we're gonna go in, and we're gonna see M58, which is a barred spiral galaxy. Our own Milky Way is probably a barred spiral. We don't have any direct pictures of it because we're inside of it, but we can measure the nebulas and star clusters and stuff going around the center, and we could roughly figure out what it looks like. The Nobody for sure knows why the spirals form. Um, they don't orbit that way. Uh, they do form a lot of stars in the spirals where the dust and gas are kind of condensing into a into a, or well, to a more dense gas. Okay, let's see if I can get my tongue around the rest of this. Okay, let's go up to Marquesan's chain. These are a chain of galaxies that were found by a Canadian group, and one pair here are the eyes, NGC 4438 and NGC 4435. Um, 4438 shows signs of an active galaxy core, active galactic nuclei, which is probably a black hole that's consuming a lot of gas. Plus, it has a lot of this tidal interaction gas and stars with its companion 4435. NGC 4435 has a lot of young stars in them. They're elliptical galaxies, which are different than our spiral. Ellipticals look like ellipsoids or almost spheres with a bulge in the middle. But it does have some young stars at 190 million years old, which are young for stars. Um, like our sun is about 4.5 billion years old, and there's stars that are older than that. So they probably had a star forming episode about 190 million years ago. Okay. The only reason I'm coming in here is NGC 4397, an object of unknown nature. I didn't look it up, but it's probably going to be somebody's research project someday. And it's considered to be in Coma Berniceus, or Bernice's Comb. And you can see a couple of other mystery objects, a couple of star clusters, globular star clusters. And a lot of these galaxies, a lot of elliptical galaxies have more than our 200 globular clusters. There's one that has about 5,900 globular clusters, and these could be the remains of galaxies that the Milky Way itself has consumed. But back over to the Virgo cluster. And here's M49. This is the one with 5,900 globular clusters, and it has a central black hole of about 565 million solar masses. And it's an elliptical galaxy. These are thought to be formed by the combination of smaller galaxies over time. So, yeah, like our galaxy has consumed has consumed a lot of their satellites. This one's consumed a lot more, and because because it absorbed a lot of the galaxies that have a lot of different angular motion to them. That's why they. Are not a tight spiral. They're more of the elliptical shape. See, let's just take a wild guess at some of these ones. Blow dryer galaxy. M100. Another beautiful spiral. Yes, I used a descriptive word. But this is probably considered a flocculent spiral because it's got a little bit of fluff in the spirals. Silver Streak Galaxy. Not the silver server, but surfer. But a lot of these could be found in small telescopes. You probably mostly just see like a cloudy haze, or the larger telescopes you'd be able to see more angular, more resolution. You'd be able to see more detail. The Virgo cluster pinwheel, M99. This is about 9 magnitude. This region is just full of galaxies. That's why they call it the supercluster. It's about, most of them are 50 to 60 million light years away from the our galaxy. Our galaxy is actually kind of like in the suburbs or the outer layers of this galaxy, of this cluster. And we're part of we're part of what is called the local group, which is us, Andromeda. I think M33. But there's like the Magellanic clouds that can be seen in the southern hemisphere would fall in the local group too. Okay. The Black Eye Galaxy. It's kind of interesting look to it. Another spiral. But you can see there's a bit of a dark edge to one side of it. Kind of looks like somebody with a black eye. Okay. M88. Another spiral, just at a different orientation. There's several different classes of shapes of galaxies. There's the spiral, which is fairly obvious. There's the ellipsoid, and there's the lenticular, which kind of looks like a cigar, or kind of like a cigar shape. And then there's the irregular galaxies, which just look like irregular blobs. And the Magellanic clouds are what are considered irregular galaxies. But here's another barred spiral, M91. Yeah. Oh. One more galaxy. I think this is a lenticular galaxy. Maybe not. No. This is another ellipsoid, M89. Oh, there's lenticular galaxies in here, but Zwicky's triplet. Okay. I didn't know they named something after Fritz Zwicky. Fritz Zwicky, yeah, was one of the people who found dark matter. He's also a very powerful individual. He was from Switzerland, and he ended up in California. There's one colorful phrase I'm not going to use because it probably upset some people. See if we can get in on one of these other ones. But Zuki was measuring how these galaxies were interacting and realized that they were moving a lot faster than they should have. So there was some unknown amount of matter in here, and they called it dark matter. The only reason it's called dark matter is because we don't know what it is, and it doesn't interact with light. There's nothing really mysterious about it. Well, mystery is what it is, but it's not as weird as some people make it out to be. It's just people that have problems wrapping their heads around the concept. Oh, okay, we'll take a look at the umbrella galaxy, and I'll call it, and then NGC 4651. And this is a spiral. You can see a jet coming off to the side. Like the black holes inside of a lot of these galaxies, when they're consuming material, they'll have two jets off of the north and south poles, and that's when the material's going into the black hole, it starts to spiral. It doesn't go straight in. It starts making an orbit around the black hole, and this creates like an electric and magnetic field, and the materials, and the material is ejected out. Excuse me. And plus, it also general relativity. The gravity forces will aid in that, probably. That's what I was told. But over the years, so that's probably what those are. That's probably what you're seeing there is just one of the jets, and right here the jet is interacting with the gas in intergalactic space and heating it up so you can see it. Okay, I think that's enough for tonight. And